Guys, I greet you all. So I want us to basically look at what shortly we call isomers for paper 2. So then now, when as a learner, you must be able to define the term isomers. So when talking of isomers, we are basically referring to organic molecules or compound with the same molecular formula but different structural formulae. For example, we can take or look at this compound. The name of this compound is what? It's pentane. So since it's pentane, it means this compound consists of how many carbons? It consists of 5 carbons. And then now, since there are 5 carbons, it means now the number of hydrogen, they are what? They are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if we are to write, this is a structural formula. If we are to change or write a molecular formula of this compound, so the molecular formula of this one is going to be C5 because there are 5 carbons, and then the number of hydrogen they are 12. So this is the what? This is the molecular formula. So from this compound, I can draw another structural formula, of which on that one my parent or my longest chain will be containing 4 hydrogen, 4 carbons. I mean to say not hydrogen, 4 carbons. Then on my second carbon, then I'm gonna introduce a substituent, of which this substituent is gonna be what? It's gonna be a methyl. So I proceed to indicate the other hydrogen that I'm missing. So there's a missing hydrogen there. So we can see that now. The IUPAC name of the first one, we said it's pentane. Now the IUPAC name of this one, it's gonna be what? The first carbon, second carbon, third carbon, and the fourth carbon. So we all can see that our parent, it's gonna be what? It's gonna be butyl because they are 4 what? They are 4 carbons, and then this compound belong under my alkanes as a result. The suffix of, the suffix of my alkanes, it's ane. So at the end of the day, my parent, it's gonna be what? It's gonna be butane. And then on carbon number 2, there is a side chain. So the position of this side chain, it is on what? It is on the second carbon. As a result, it's gonna be 2 hyphen. Mind you, we said if you are to separate numbers and alphabet, then we use an hyphen. So it's 2 hyphen. The name of the substituent or the side chain there, it's a what? It's a methyl. And then it's gonna be what? It's gonna be what? It's gonna be butane. So you can see that the IUPAC names, they are different, but on the same structure. If we are to write the molecular formula of it, it's going to be C5 because still there are 5 carbons, and then the number of hydrogen, they are still what? They are still 12. As a result, we can say the first compound and the second compound, they are what? They are isomers. Same molecular formula, C5H12, but different structural what? Different structural formulae. So then again, as a learner, you know that isomers, they are categorized into 3 categories, of which we've got what we call a chain isomers. Then the second one, we've got positional isomers. Then the third one, we've got functional isomers. So when talking of chain isomers, what are chain isomers? We are basically referring to organic molecules with with the same molecular formula, but different types of different types of chains. So when saying different types of chain, we are basically addressing the part of the chain length, or we are basically addressing the issue of the surface area. So if we are to compare A and B, we can see that structure, I mean compound A, it's less branch, but now compound B, it's more branch than what? It's more branch than compound A. I can draw another structure from this one where we're gonna have 3 carbons in our parent chain. Then on the second carbon, we introduce what we call the methyl. Again, on the second carbon, we've got the second methyl, then the missing bonds here, because as a learner, you know that each carbon must be surrounded by 4 bonds. So if we are to write the correct IUPAC name of this one, then it's going to change. This one is going to be what? 2,2 hyphen what? Dimethyl, and then what? Propane. The first one is pentane. The second one it's 2-methyl butane. The third one it's 2,2, because to separate a number from a number, then we use a comma. 2,2-dimethyl propane. So now we can see with more compound A, B, C. These ones, they are what? They are chain isomers, because you can see that compound C, it's more branch than compound B and what? And C than B and A, I mean to say, meaning as we move from compound A to C, the surface area decreases, or the chain length become what? It becomes shorter. We decrease the surface area. Now, as a result, compound C has the what? Has the highest vapor pressure, and compound C has the lowest boiling point and what? And melting point. Then now the intermolecular forces in compound C are the what? Are the weakest. Meaning now compound A has the highest boiling point, the highest melting point, and the what? The lowest vapor pressure. As a result, the London forces in compound A are the what? Are the strongest. Therefore, now we need more energy to overcome the intermolecular forces in what? In compound A. So basically, shortly, the issue of chain isomers addresses the issue of what? Of surface area. It's either you are making the compound to be more branch, or you are making the compound to be what? To be less branch. So as the molecule of the compound it's less branch, it means the surface area increases, or the chain then become longer. So as the surface area increases, the boiling point increases, the melting point increases, the vapor pressure decreases, the strength of the intermolecular forces, they become strong. The amount of energy required is what? More, we can say more energy is then what? Required to overcome the intermolecular forces. That's the first part. Then secondly, we've got what we call positional isomer. So then now, when talking of positional isomers are molecules or organic molecules with the same molecular formula, but different position of the what? Of the functional group, or we can say the what? The substituent. So again, let's consider this part where we are forming an alcohol. Remember, alcohols, they belong to the hydroxyl group. So you can only see an alcohol by OH. So we are introducing OH so that we change this whole thing. It becomes what? An alcohol. So the name of this one is going to be what? It's pent-2-OL. So this 2, it's telling you the position of the what? Of the hydroxyl group. It means on carbon number 2 of your longest chain, then you've got what? You've got the hydroxyl group. So from this, if I want to form a positional isomer, what is it that I'm going to do? I'm going to change the position. I'm changing the position of the what? The position of the hydroxyl group. We are saying same molecular formula, but different position. So we can shift this hydroxyl group into the what? Into the first carbon, as we are shifting it from the second carbon to the first carbon, then we are forming what we call positional isomers. So they are molecules with the same, or organic molecules with the same molecular formula, but different position of the functional group or of the substituent. So we can see that the IUPAC name of this one now, it's gonna be what? It's gonna be pentane -1 OL. So you can say it's 2 versus what? 2 versus 1. So the one it's saying to you, the hydroxyl group, it's now found on the what? On the first carbon. The 2 here, it's saying to you, your hydroxyl group, it's found on the what? On the second carbon. So this is an example of what? Positional isomers. It can also work where you've got what we call a halogen. For example, we can remove this hydroxide, replacing it by what? A halogen. And then you know that a halogen are those elements that are found on the what? On the periodic table, where we're talking of bromine, where we're talking of chlorine, where we're talking of fluorine, where we're talking of what? Of iodine. Those elements that are in group 7 of the periodic table are halogen. So we can use a halogen here, then which is our PR here, then we change the position of the PR to the first carbon. Still it's a what? Still it's a positional what? A positional isomer. Then the last one, we've got what we call functional isomers. Functional isomers, what are functional isomers? Are organic molecules with the same molecular formula but different what? Different functional groups. Same molecular formula, different functional groups. Then as a learner, what is it that you need to know? You need to know that we've got what we call ketones and aldehydes. So ketones and aldehydes, these two, they are what? They are functional isomers. For example, with regards to ketones, we know that the functional group of ketones, it must be found between how many carbons? It must be found between 2 carbons. So immediately when you change the position of this CO, which is the functional group of ketones, you change it, moving it to the first carbon, automatically you will be changing the ketone into a what? Into an aldehyde. Again, we've got what we call carboxylic acid with esters. Carboxylic acid and esters, again, they are what? They are functional isomers. So it means on a question paper, if they give you a structure, and then you can see that this is a what? This is an ester. How do you see an S? You can see an S with what? COO. So this is the what? This is the functional group of what? Of esters. So if you can, they say to you, they give you an ester, and then they say to you, draw the functional isomer, or draw a structural formula of the functional isomer of this compound. They are basically saying to you, change this ester into a what? Into a carboxylic acid. The same thing again. If you give they give you the carboxylic acid, and then they say draw a structural formula of the functional isomer of this carboxylic acid, they are saying to you, change this carboxylic acid into a what? Into an ester. So these are the few things that as a learner, as I lead you, we push into our final examination. These are the things that you've got to what? You've got to bear in mind, so that you cannot do what? You cannot make those minor mistakes. Thank you for watching. Please follow me for more.